Where is quick time? Quick time. Oh, sorry. it's showing my face only. Oh, what is this, bro? Hey, sorry. Actually, I think I'm streaming right now. Huh? I think I started streaming. I'm not sure. Plan your engineering basics. God, help me. Where is that one? Let me create another board. Sorry, so sorry, guys. I'm little disturbed, and reason for that is simply like I just my internet wasn't working. No, not disturbed. Sorry. So jokes apart. Okay, let me go to the live section and see if everything is working. Then we'll start with the introduction as usual. So first thing, always remember you have to speak louder. Disturbed. Okay, and irrespective way
reason for
that
is simply
your voice decides like how confident you are. So first of all, welcome to high entropy, and we are going to solve DSA problems, and it is day 53 of DSA learning. So I'm little late, but everything is going great. Oh man, I'm getting call. Just I need to. हेलो. हाँ अभी सही है, चल रहा है. मैंने बस उसमें वायर सही से नहीं लगे हुए, वो मैंने एक वायर मिला था. हाँ अभी सही आ रहा है, पहले से बहुत अच्छा है. हाँ ठीक है, थैंक यू. Okay, internet was not working, so I went out and fixed it by my end. It's like I need to change the direction. The direction wasn't good, so that's why my landlord called me. Okay. Okay, so by the way, now something is not going good. I think camera stopped working. By the way, thank you. Yeah, so I was introducing myself. Okay. No, not introduction. It's yeah, everything is good. And now let's jump into the DSA 53 day, and our goal. What is expectation for today? So first thing, I don't need to panic. I sometimes I start panicking like, and I'm not thinking from the what we say. I mean, sometimes I just start and get diverted or something happened few days back, like I was not, the problem was simple. So today I'm expecting to make less mistakes and solve it on the time, and think about the corner cases, like what are the corner cases and all, and that's all. That is the expectation. And yeah, so I'm targeting like maybe 30-45 minutes. I can't commit, but yeah, I'm not targeting that much time. What I'm saying, even I'm not getting. So let's jump into the dynamic programming section. And if you know, it's a drivers DP sheet, and I'm just subscriber, or you can say I took the subscription, so that's why. Okay, let's see how this problem is, like what kind of problem it is. If I have solved the next one is, I know, count subsets with some k. This is similar to this. Instead of true false, you have to count all the subsets. Okay, so it's a similar problem, similar to this. Count partitions with given difference. This is also kind of similar to these problems, but counts, I don't remember partitions. A set into two subsets with minimum absolute sum difference. Okay, let's see. We are here to learn. So partition a set into two subsets with minimum absolute sum difference. Minimum absolute sum difference. Partition a set into two subsets I think I heard somewhere like this problem also. It's 0 1 knapsack problem. I mean, yeah, knapsack problem similar to the knapsack. Our goal is to minimize this absolute sum, and if you see numbers, what is the numbers? It won't be negative, right? Where is the constraints? Yeah, so it will be number will like element will be greater than 0 and less than 10 to the power 5. Sum of higher elements 10 to the power 6 less than or n into sum of higher elements. Okay, that means all the elements sum, and if you are multiplying it with the n then also, so not sure what is the reason behind it multiplying it with n, and then you are calling like it will be less than 10 to the power 6. Maybe we can get a clue from it, but okay, I'm just confused with the set. Is it the set into two subsets? Partition is set into two subsets. So set, I'm assuming like everything will be unique if it is set two subsets. I mean, yeah, so if it is set then definitely there will be a unique item only. So let's say we have given 1 7 14 5 and another is 3 1 6 2 2. 3 1 6 6 and 2. Wow. So let's start with this one, and our goal is to minimize the subset sum. 1 7 14 5. So I can see, so first thing is, if you will multiply, if you will take these numbers and this one, then it will be 13, and 13 14 absolute will be 1. That is the max possible absolute. If you will take anything, like if you will add it here, then definitely this will be. So if you think closely, I mean, it's like we need to get the value closer to the half. So what will be the total sum? 7 1 5 13 26 1 27. It's 27. So okay, what is the possible range for the absolute sum difference? You can say you are keeping everything in the one set and you are keeping nothing in the another set, then that will is 27, and here you will keep 0. So max will be 27, that is possible, and min can be so it will be 27. Okay, and minimum, that means if you are able to divide it into two equal parts, that means it will be like when you will take absolute difference, it will be almost, not almost, it will be 0. There will be no difference between these two. So you can say 0 to 27 will be the range. And okay, so I'm thinking about something like, can we solve it using binary search? Here I know DP, but might, like, if I have to think, then I might have to think about the, if you will give it me as a random problem, then I might thought about the binary search, that I will take okay one target value from it, and then I will check like can I get that target, and every time whatever the target that I will get, my goal will be to reduce it to lower value if I can get, and then you will see the maximum possible value that you can get from it, and you will see if you can get that sum from each time. So it's like you are going to take order of n log n time, right? Because every time you are going to search binary log n time, and you are going to search for the numbers sum if you can get. Okay, yeah, I think so. If you can get the sum, target sum, then that means good, well and good. Otherwise, but still there will be chances. I mean, might need to sort the elements. Oh yeah, I need to sort them. If they are sorted, then well and good. Otherwise, it will be like order of n square or n log n you will take to sort, and then you will do apply binary search, and then what you will do, you will search, so order of n, so log n, and then that will be like order of n log n to to sort plus order of n log n to binary search, where you will start searching from this like binary search on result, you can say, and order of n to calculate sum. The numbers are sorted, then you will just pick one by one. Okay, let me pick this number. If we can get, shall I have out? I think it won't work, because if you will do that, suppose it there is like you are targeting, you target value is 5 and you are getting 1 0 1 3 5, so you will start, okay, let me take this, so you will say, okay, great, I am taking this, then you will take 1, and it's not like you have to take continuous elements, so that's why the problem will be like you will end up, you won't be able to decide like order based on order of n, if you can get the subset out of it, because you can take subset, right? You don't need to take each element, so there will be problem. Okay, so what else we have? What are the options that we have right now? I think more. So first thing, we have our items like 1, what was the items like 1 7 14 5, and now we need to put into 2 bags. You don't need to put into 2 bags, like suppose you are getting some x here, so here you will get what, s minus x, s is total sum, so can I say I wanted to say something else. You got the sum of all the elements, x plus s minus x equals to s, then it will be something like s equals to s. What's the point here? No. Bro, so I forgot the solution of it. I mean, I never remember the solutions, and that's a good thing for me, at least, because I'm not memorizing the things. Okay, but bro, how will you solve it if you don't know how to approach it? I mean, if you need minimum sum, that means you need to target for a value. I remember something from that particular, like I watched a video and it's similar video. So if you wanted to minimize, if you wanted to absolute, then what is, if you get mid value, if you can achieve mid or near to mid, then you can say, okay, if I'm able to get this mid value or near to mid value, that is the maximum possible value that you can get from one in the one set, so remaining will be from another set, and then you will get the maximum, like minimum absolute difference. So our goal will be to find a value that is closer to the mid, are equals to mid. Okay, so first thing you can decide based on the mid value if it is going to closer to mid, and another one you don't need to check, it will be like similar to that. So okay, now let's think in the terms of recursion how we are going to do it. Every element has two options: take, not take. Okay, well, good, but what you will get from this? I mean, I just wanted to solve it using recursion if possible. I know tabular approach we can use, and I'm gonna use that approach, but before that, I just wanted to understand. So every time you are going to check, like you are at 0, I equals to 0. I mean, there will be multiple options, right? You will say if you are at I0, then you will, when there are two options. If weight is less than mid by 2, if it is greater than mid by 2, then it won't be the right approach. Okay, so target, let's say target will be something like target will be less than equals to mid by 2 or mid by 2, you can say. So whatever you are getting, so that is the max possible value you can achieve. And I mean, not mid by 2, s by 2. So target, and what you will do, say if you can achieve the target, then well and good, but if you are not able to achieve the target, what you will do? I mean, if it is area of I less than equals to target, then you can consider it, or maybe you can say current values whatever we have right now, and plus if you are adding this and it is less than equals to target, then consider. And another one is not consider. Okay, but what is relevance of it? If I'm do, I will do this 117.14.5, 17.14.5, 17.14.5. I got these numbers. Now the thing is, I need to, so one has two options, either consider or not consider. If I consider, then 1, if not consider, then 0. Then you have 7. 7 has two options, you will consider or not consider. So 7 if you will consider, then it will become 8. If not consider, then it will become wait 1. And here right now 0, then 7 if you consider, then it will become 7, it will become 0. Now another option, now you are going to this and this explore. So 8, now have 14, you have options like if it is less than this, then you will consider. If we still, so our goal will be like 7, 5, 12, 1, 13. 13, 14, 13 by 2. So 13 target will be 13, like 13 or 1 8. Oh god. हेलो. हाँ भैया, आप नीचे नीचे आ गए हो क्या? हाँ राइट मिनट में. 320 है आ रहा मैं. Oh god. Actually, I have to use mic here. I placed it somewhere else. I'll be back, man. Not mine. Whatever is the audio, I will keep it as it is. Just 1 minute. I'm back again. So bad. Now I'm going to just give me a minute. God, something. Oh, 10:24. I have to keep garbage outside. I have to function F. Where is function F? Hey bro, what's wrong with you? Wow, great. Camo, come on, Camo, wake up. I wasn't expecting this. Hey, what's wrong with you? Hello, wake up, bro. This is not fair. What the heck, man? Finally working. Yeah, so I'm not getting recursion. How can I solve it using recursion? Okay, so what I wanted to say, we can solve it using recursion, but for that I need to check for each target that is possible. Yeah, so you can say, I will check for target 13. So I will start from top, and whatever we'll get will stop there. That is max possible. Other option is, okay, so it will take little time to close, because no, it won't take time. I think 13. So you will say, okay, can we use the memoization for it? I think yeah, it will be easy. First we need to calculate, and after the target, like you will create a target table. Memoization table will be something like you are going to consider from 0 to target, and then you will say, okay, 0 1 2 3 4 and dot dot dot. These are the number of elements that you are selecting have, and what is target value. Okay, so we'll try it, but first we are going to try tabular method because that will be easy, and after that I will be like I'll have dinner and I can go out as well because today I wanted to go out. Okay, so let's focus on the second approach. So table approach. What we are going to do? Target you can get maximum. You can say sum pi by 2. Okay, so this is what you'll say target. So we are going to say, okay, minimum value possible 0 and 1 dot 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 target. Okay, so this is the value. So you can say the array size will be target plus 1 columns, and number of elements in a row you will say it could be 0, it could be 1, it could be 2, and it could be just n minus 1 number of rows. Okay, so looks everything good, and now the thing is how we are going to fill it. And one more thing, I just remember, we don't need to use complete array. Okay, no. First, let's clarify everything. That means if you want 0 value, number of elements you have 0, and target value that you are expecting, that is also 0.